Hi. So today we will be talking about software quality. Now, when the term quality comes in front of us, there are a lot of perceptions that we have. So if I ask you what is quality, what will be your definition? What will be your answer? The other day I was talking to a friend and he was saying, you know what, some of the cars like Alto and all are not a good quality car. I said, why do you say that? In my opinion, they are because they do conform to the standards that they are made against. So how can you say they are not good quality cars? You can compare the quality of a product with another product in the same make and model. You cannot compare the quality of an Alto with, say, a Mercedes Benz, because they are made against different standards, right? But then, of course, as a user, will you will say, but it does not meet my requirements. Then, of course, you should move to the product that moves matches your requirement, right? So, if you see this conversation, it gives two views about quality. One is the producer's view, which is the manufacturer or the maker of the product, or in software terms, it is the application or the software product that we are talking about, or a mobile app, for example. So the producer or the developer organization, they define certain standards and say that my program or the code or the app or the functionality feature application, etc., will follow certain predefined standards, and these are those standards, and that will of course depend on the technology chosen. Then the other view is of the consumer view or the customer view, the person who is consuming that product. In case of cars, it is the user. In case of software product, it's the or the application user, right? So does it meet their requirements? Is it fit for use? And does it conform to the standards? So these are two broad definitions of quality. If you want to define it in a simple term, you can say that fit for use and developed right in the first time. Now, that is very critical. First time. Suppose I am making a car, or suppose I am writing a software application and I keep doing rework. Is it quality? No, because I am doing it, I'm dismantling my work, then I'm doing it again. A lot of waste I'm creating, right? That waste is waste of time, is waste of resources, is waste of money. So any wastage is actually against quality. So fit for use, developed against predefined standards, and done right the first time is the definition of quality. Now, how do we achieve this quality? So there are a lot of ways in which you achieve the quality, and predominantly you plan for quality. So when you plan for quality, you define certain strategies, you define certain processes, you define best standards, best practices, guidelines, principles, standard operating procedures. So these are part of your quality plan. And once you make a plan, you create responsibilities, who will do what, right? And then you have specific milestones. Okay, when the testing will be done, when the reviews will be done, how frequently I will review my standard operating procedures, and then you keep on refining your process. You keep reviewing, you keep finding issues, you keep working towards continuous improvement. So you define a strategy, you have resource planning, you have timelines. Then of course you have certain tools which you want to use for ensuring quality. You can have bug tracking tools, you can have testing tools. For example, in software parlance, you use defect tracking tools like Jira, or you use automation tools like you have a Selenium framework for test automation, so on and so forth. And then also you define a certain metrics. Okay, you would define certain metrics for a product, that my product should have, suppose you are making a software application which is a web-based application. So you have some non-functional requirements, that my web all my web pages should come up within 1 second, right? It should not take more than 1 second to load. If you are returning large record of data on your screen, then you will say, okay, how soon the data should come in, right? So those are certain metrics, and then you define metrics for your code defects, that okay, not more than x number of defects per lines of code, or per function point, or per class file that I have. So do you define a lot of metrics and we can have another session on metrics, what software metrics we can use. So these are all part of quality planning. Then two terms which you would have heard a lot whenever you work in software quality field. One is called quality assurance and one is called quality control. What's the difference? Assurance, as the word says, you are assuring the quality, right? How do you get it? You define standards, you define your best practices, you define your processes. So these processes and practices, what you define, the effort that you spend in defining these are your quality assurance effort. And when you actually review and test a product, right, that's actually quality control, because then you test it against certain guidelines, you test it against certain metrics, and then you say whether it is within the metrics, defined metrics, or it is outside of the defined metrics. So when it is outside the defined metrics, then of course it's a defect, and then you take steps to control those, and whatever steps you do to prevent are assurance step, whatever steps you take to check the quality are your control steps, right? Now what happens when you do quality control? You of course find defects. When you find defects, you should do a root cause analysis, and the root cause analysis, whenever you look at any issue or a defect, the first thing that you look at is not the main cause of the defect. Those are essentially symptoms. But to find the root cause, you should ask 5 whys. There are certain techniques, 5 whys. If you say why this issue happened, so you get certain answer. Then you will ask, okay, why this happened? And you get another answer. Then you ask why this happened, and you go 5 levels deep. Typically 4 to 5 levels deep, you will find the actual root cause of why it happened. The others could be just symptoms. So you should not work at those symptoms, but you should work at those root cause. Now, when you identify the root cause, right, one is of course corrective actions that you take immediately to fix it, because you have to take the application to production or take the product to live environment to the user. So you correct it and then you take it forward. But at the same time, you also want to make sure that future releases or future production should not have that issue, right? So then you put something called as preventive action. So you find defects. You can also call this non-conformity or also called as NC, and then you do preventive action and corrective action. It is also called as CAPA or CAPA in very crude manner. So NC and CAPA, right? You will hear these lot from quality professionals. Now, whenever you do this, you find the root causes, and you can actually in a sample environment, you can actually segregate your root causes into certain categories, and you can list your identify how many defects or how many issues are in which category. So whether it's a developer oversight, whether it's not following standards, whether it's not knowing the standards, there can be various causes and categories. So if you segregate those and put your defects and put a um, cumulative chart, you will find something called as a Pareto chart. And when you put a Pareto chart, you can identify top 20% of the reasons which cause top 80% of the issues. It is called as 80-20 rule. So the reason is, if you address those top 20%, you can actually get rid of your your 80% of the issues in your inner process which are causing those issues. And every you do regularly what is called as, in software parlance, what is called as defect prevention meeting. um, like every 30 to 45 days, you can say, we will review the defects which we are finding in the system while doing our testing and reviews, and we will keep analyzing those, keep doing root cause analysis, keep doing 80-20 rule, and we will keep resolving the top 20%. And when you do that, you embark on what is called as a continuous improvement journey, which is what CMMI level 5 actually prescribes. So we can talk about CMMI and those things some other time, but for now, a continuous improvement you can understand this way. So when you do all these activities, you are assuring quality, you are controlling quality, right? So of course you are spending effort, you are spending time, right? So then when you spend effort and time, there is a cost, right? So what is called as cost of quality? So cost of quality is that effort and time that a team spends on achieving quality. It can be the cost involved in assurance effort, it can be the cost involved in the control effort. Um, and we can also divide this cost of quality in different ways. One way is defining it as a cost of conformance versus cost of non-conformance. So cost of conformance, if you see, so we are defining standards, like we talked about standards for a Maruti Alto car or standards for a Mercedes Benz car, and the effort which you take to define those standards and effort that you take to meet those standards before it goes to the users is called as cost of conformance. So anything before it goes to the user is cost of conformance. Any cost once it goes to user, after it goes to user and a defect comes in, it is cost of non-conformance, because that means you have to uh, that is why many manufacturers or many software developers also provide a warranty period. So if any issues happen within 6 months or 1 year, we will fix that free of cost. So it is free of cost to the customer, but of course you are spending effort and time, so it is not free for you. So that is why it is cost of non-conformance. The other way to understand cost of quality is to understand it with respect to prevention, appraisal, and failure. So prevention cost is the standard, the effort you spend on defining standards, defining best practices, processes, and procedures. That is your prevention, because you are putting those things. So if your team follows that, they will avoid many defects. So those defects will not occur in the first place. Appraisal cost is when your team has probably not followed those standards procedure, or something was done which did not come in the purview of that procedure that was defined, and you found it in your testing before it goes to the customer. That is called as review and testing cost, and also called as appraisal cost. So something that you find after the product is delivered, but you are testing it before it goes to the end user. And the failure cost is after it goes to the end user. So if you look at it, the appraisal cost is 7 times that of prevention cost, and failure cost is 31 times that of prevention cost. Which means that the cost that you incur after this product is live in production or with the user is way higher than the cost that you would incur to prevent that issue. So that's why it is important that you put processes and practices in place, because it may look like an effort that, okay, I'm following best practices, I'm writing my code as per standards, somebody has to define the standards, somebody has to keep updating the standards. It may look like a big effort, but trust me, it is much smaller or much lesser than the effort that you may have to spend to fix a defect in the system, right? So these are the various ways in which you should understand quality. I hope this session will be helpful for you guys. Thank you.